In this video, we will go over datums in mechanical engineering with a practical example. Let's jump right in. Let's say I want this 50 by 50 millimeter part to be machined, so I will create an engineering drawing that looks like this. Let's focus on this 50 millimeter height dimension for now. Now we can measure this 50 millimeter height dimension in a couple of ways. We can measure it from bottom to top, or we can measure it from top to bottom. But how do we specify a consistent measuring reference point? So here is our problem number 1. We need a reference point. Next, we know that every surface has some irregularities. Since nothing is perfectly flat, our part will also have a surface roughness. That proposes a new problem. Here the red zigzag line shows the surface roughness on the top and bottom of our part. How do I reduce the difference in roughness height from my final measurement? So I need a perfectly flat reference point as well. To overcome all these problems, we specify datum features on a part. A datum is a theoretically perfect line, point, or a plane from where dimensions are referenced to. In our drawing, we have two datum simulators, A and B. Pay attention, I did not call A and B as datum, but I call them datum features. Since our part is not perfectly flat, we need a datum simulator which has a finer surface finish as compared to our part. In real life, this datum simulator is usually a surface plate or a granite plate. In our example, the bottom surface of our part is referenced as datum feature A. We will place our part on top of a surface plate which will act as datum A simulator, and from there we will take our zero reference dimension. Now similarly for datum B, we will use an angle plate to act as a datum B simulator. Datum A and B simulator are perfectly at 90 degrees with respect to each other, and they define zero reference points for our height and width dimension. Here are some real-life examples of datums in action. In the bottom image, you can see that the part is sitting on a granite plate. The surface of the granite plate is acting as a datum simulator A from where the reference dimensions are taken. Similarly, on the top image, you can see